Hey students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 5.8, Linear Inequalities, boom shakalaka. And you ask, what is a linear inequality? Well, a linear inequality, sorry, I can't talk right now, is similar to a linear equation, but uses an inequality symbol. And then, what is the solution to a linear inequality? Well, it's just like the solution to a linear equation, or any equation for that matter. A solution is all the ordered pairs that make the inequality true. Okay, now I want you to think about that for a moment. The solution is all the ordered pairs that make the inequality true. And in inequalities, linear inequalities and all inequalities, we have infinite numbers of solutions. So here's some examples, and this will give you an idea of what it means for an ordered pair to be a solution. Basically, does it make the inequality true or false? If you plug in an ordered pair and it makes the inequality true, then it's a solution. If you plug in an ordered pair and it makes the inequality false, then it is not a solution. Very simple. So let's check it out in action. 2, 5. So this is my x, this is my y. So 2 times 2 minus 3 times 5 is less than 15. So I'm just plugged in 2 and 5 for x and y. 2 times 2 is 4. 3 times 15 is 15. 4 minus 15 is negative 11. And is negative 11 less than 15? Yes. This is the solution. All right. Negative 1 and negative 7. 2 times negative 1 is negative 2. 3 times negative 7, or you could view this as negative 3 times negative 7. This is going to be positive 21. And negative 2 plus 21 is 19. Is 19 less than 15? Well, last time I checked, it wasn't. Not a solution. All right, 3, negative 4. 2 times 3 minus 3 times negative 4 is less than 15. 2 times 3 is 6. Negative 3 times negative 4 is positive 12. And 6 plus 12 is 18. Last time I checked, 18 was not less than 15. So this ordered pair is also not a solution. And last but not least, the ordered pair 0, 0. Well, 2 times 0 is 0. Negative 3 times 0 is 0. Oh, got 0 happy. Is 0 less than 15? Yes. 0 is less than 15. Therefore, the ordered pair 0, 0 is a solution to this inequality. All right, so we understand now what a solution is to a linear inequality and how we determine if something is a solution by plugging it in and evaluating the inequality. If it leaves a true statement, it's a solution. If it leaves a false statement, it's not. Now, graphing linear inequalities is a way to show all the ordered pairs that are solutions. And so here are the steps to graph. Put the inequality in slope-intercept form. Be sure to flip the inequality symbol if you multiply or divide by a negative number. This was a lesson from solving inequalities that we had in Unit 2. So don't forget, if you ever multiply or divide both sides of an inequality, you have to flip the inequality symbol. Then you graph the line. You use a solid line for less than or equal to, greater than or equal to symbols. And you use a dotted line for less than or greater than symbols. You shade above the line for greater than or less, greater than or equal to, and you shade below the line for less than or equal to. All right, so here we have our equation from above, and we need to convert it to slope-intercept form because we're going to graph it. So here we go. We need to get x on the other side and isolate y. So I'm going to subtract 2x. Okay, negative 3y is less than negative 2x plus 15. Now I need to divide by negative 3. And here I am dividing by a negative number on both sides. So I know I'm going to have to flip the inequality symbol. Negative 2 divided by negative 3 is positive 2/3 x, and 15 divided by negative 3 is negative 5. So negative 5 is my y-intercept. That is right there. And then my slope is up 2 over 3. So up 2 over 3. And there's my line. Now, since this is a y is greater than is shading above the line, and this is also a dotted line. Okay. And I shade up here. Now, you might be asking yourself a couple questions. Why is it a dotted line? And why did you shade everything above it? Well, everything above this dotted line makes the inequality true. If you don't believe me, pick a point. Let's pick the point 0, 0. 0, 0 is a really easy point to evaluate. And up here, when we did 0, 0, it was a solution. Okay, and you could pick any other point, 2, 5 was one that we did. That was right there. Okay. We already proved that that's a solution. Now, why is it a dotted line? Well, I want you to take the point right here, okay? You can take the point 3, negative 3, and you can plug it into this equation, and you'll see that it does not make the inequality true. This line is dotted because all the points that are on this line are not solutions to this inequality, only the points that are above it. Hope that makes sense. All right, here we go, moving on. Got some more examples. A couple of these are already in slope-intercept form. So all we need to do is start to graph. All right, so y is greater than 1/3 x minus 5. So the y-intercept is at minus 5. And the slope is 1/3. So up 1 over 3, up 1 over 3, up 1 over 3. There we go. All right, so I'm going to attempt to make this line as straight as possible. Not too great, not too bad either. All right, so now I'm going to have to go back and reference the previous sheet. This is greater than, so this should be, and I messed up. I'm going to go back. This should be a dotted line. And it's a dotted line because the points that are on the line are not solutions. And then since it's greater than, we're going to shade above. So all the values above that dotted line, all the ordered pairs in this space up here where I'm shading, will make that inequality true. And if you don't believe me, pick one and plug it in and see. All right, number 2. Start at negative 1. The slope is down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Since this is less than or equal to, this is actually going to be a solid line, okay? Solid line. And since it's less than or equal to, we're going to shade below the line. Right. Number 3. Here we have an equation in standard form. Let's convert it to slope-intercept. Subtract 5x. Divide by -2, and since I'm dividing by a negative, you guessed it, I need to flip the inequality symbol. -5 divided by -2 is positive 5/2x, and 12 divided by -2 is -6. So I go to -6 on the graph, on the y-intercept. My slope is up 5 over 2. Up 5 over 2. And since this is a less than symbol, I'm going to have dotted line, which means that these points on the line are not solutions. And I'm going to have to shade below. There we go. Number 4. Subtract x from both sides. Okay. Divide by -4. And since I'm dividing by a negative, I need to flip the inequality sign. Okay. All right, so I flip my inequality sign. Here's my new equation, or my new inequality in slope-intercept form. Plot the y-intercept at y equals -2, and the slope is up 1 over 4. Up 1 over 4. Down 1, left 4. Down 1, left 4. And since this is greater than, I have a dotted line. And since it's greater than, I have to shade above it. Now, these rules, you guys are fortunate that you'll be able to use your notes on the quiz, so you won't have to memorize these yet, but I challenge you to get these stored away in your memory bank because you won't be able to use your notes whenever you take the EOC. All right, number 5. Subtract x from both sides. -y is greater than or equal to -x plus 8. Divide by -1. And when we divide by a negative, we have to flip the inequality sign. -x divided by -1 is positive x. And hopefully you know now that if there's no coefficient in front of a variable, there's a 1 there, okay? And I didn't have to put 1 there, but for the purpose of explaining this to you, I wanted to. All right, so there's my equation, or I'm sorry, my inequality. I said it again. Plot the y-intercept. Slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And since it's less than or equal to, this is going to be a solid line. And less thans, we shade below. There you go. All right, number 6. Subtract 3x from both sides. Divide by 2, and since we're dividing by a positive number this time, we do not have to flip the sign. And I'm not going to write +0 here because if there is no y-intercept in a linear equation or a linear inequality, then the y-intercept is at the origin. It's at 0, 0. And then use the slope from the origin. So down 3, right 2. Down 3, right 2. Down 3, right 2. And since this is a less than symbol, we're going to have a dotted line. And since it's less than, we're going to shade below. All right. Number 7. This one is interesting. Y is less than or equal to -4. Well, when it's y is equal to -4, it's a horizontal line, and that's what it is here as well. Since it's a less than or equals to, it's going to be a solid line. And since it's less than or equals to, it's going to be shaded below. Last but not least, x is greater than 7. Well, this is a vertical line at x equals 7. And since it's greater than, this is going to be a dotted line. And we're going to shade above. But that's really confusing because this is a vertical line. So how do I know? Well, pick the point 0, 0. Is 0 greater than 7? No. That's a false statement. So if the point 0, 0 makes this inequality false, then I shade the other side. And anytime you have confusion about where to shade, I challenge you or invite you to pick a point on that side of the inequality, on that side of the line, and plug it into the inequality and see if it makes it true. If it makes it true, then that's the side you shade to. If it makes it false, you shade to the other side. I'm your teacher. This is the way.